Hello and welcome back again to our channel on mathematics. We'll be looking at binary operations, and in our previous videos, in the 1 minute short videos, we've been doing some lectures on binary operations, but today we're going to dedicate this long video to questions and answers or practice questions on binary operation. It's our first part video. If you're ready, join me and let's zoom straight right in. So let's imagine for a second that we have this question, we have this problem here. The problem says that a binary operation star, a binary operation. So we have a binary operation star like this. Is defined on a certain set, let's name the set A, all right? And then the set A here, the set A that we are talking about, is made up of these members or these elements or numbers 2, 3, 5, and 7. Now, the binary operation star itself is given as A star B, which is equal to A plus B, sorry about that, A plus B. Let me wipe that off. This is given as A plus B minus 2, A plus B minus 2. And we have both the A, both the A and the B, both the A and our B, they belong to they are members of the set A. They belong to the set A, or they are elements or members of the set A. All right. Now, the main question says we should copy and complete this task here. To first of all, we should complete this table. Sorry about that. First of all, we're going to complete this table. Sorry about that, please. First of all, we're going to complete this table. And once we complete the table, we're going to show whether the set A is closed under the operation star, under the binary operation star. So that's the first thing. We're going to draw a table. And it's made up of 2, 3, 5, and 7. And then on the horizontal side too, we have 2, 3, 5, and 7, like that. And then we have the star. The operation is a star right here, like this. Now we've been given some of the numbers. Some of the numbers has already been given. The first row has been given as 2, 3, 5, and 7. The second row, some of the numbers are missing. So we have 3 here, we have 4 here, and then we have 8 here. Then the next one, we have a 5, and then we also have an 8 here. So there are quite a few that is missing. The next one is we have a 7 here, we have an 8 here, we have a 10 here. And we're being asked to complete this table. And once we complete a table, we are being asked to confirm whether this set A is closed under this operation star. Now, how are we able to fill in the spaces first? What are we going to do? We already know that A star B, we know that A star B is A plus B minus 2. This is the operation. This is a binary operation that we're dealing with. So if we want whatever is here, it is basically this 3 star 5. This 3 star 5. So we're going to put it in 3 star 5. We're going to substitute it in there. Now, it means that our A is 3 and our B is 5. So wherever we find A, we put 3 there. And wherever we find B, we put 5 there. So here we're having an A, which is 3. We're also having a plus sign here. And our B is 5 minus 2. And we end up getting 8 minus 2, which is equal to 6. So it means that the missing, what it means is that the missing number here is 6. Now, what about here? Here we are looking for 5 star this 3. 5 star this 3. So what are we going to do? 5 star 3 is going to be 5 star 3, which is equal to the A is 5, B is 3 minus 2. And we end up getting 8 minus 2. It also gives us 6. So here is a 6 as well. What about here? Here we are going to have a 5 here and a 7 there. So it's 5 star 7. Our A is 5, our B is 7 minus 2, and we end up getting 12 minus 2, which is 10. It means the missing number here is 10. Now we have to complete this last one here. It's 7 star 7, 7 star 7, 7 star 7. The A is 7, the B is also 7 minus 2. We get 14 minus 2, and that gives us 12. It means the missing number here is 12. Now, for us to be able to confirm whether the set A that we have drawn, this table that we've completed, whether it is closed under the operation star, is it closed under the operation star? What it means is that it is closed if all these elements in this table, all these elements or numbers in this table, if they are found in this set A, then it is closed. But if it is not, if some of the numbers are outside the set A, then it is not closed. Now we can tell that this 2 here is here. This 3 is also in the set A. 5 is there, 7 is there. 3 is there, 4 is not. What about 6? 6 is also not. What about 8? 8 is not. So we have enough evidence to support the idea that the set A, sorry about that. We have enough evidence to support that the set A is not closed. It's not closed because we have some of the numbers in the table that are outside the set A. It's not closed because some of the numbers, right? Some numbers in the table are outside of the set A, All right. So that solves the A portion of our question. The A portion that solves it. Now, what about the B? What about the D part? What about if you're asked to evaluate 3 star 2 star 5? How are we going to do that? Now remember, don't forget our PEMDAS. Our PEMDAS says we should start with the parentheses first. So we're going to start with 1 here. So it's going to be equal to 3 star, the 2 star 5. The 2 is our A. Don't forget, this is our operation. This is our binary operation here. So our A is going to be 2. It's going to be 2. And our B is going to be the 5 minus the 2. We're just plugging in A and B into this operation here. And we're going to have 3 star into 7 minus 2, which is 3 star 5. And once we get here, this also becomes our A. This becomes our B minus 2. And now we get 8 minus 2. And our final answer will give us a 6. Now, I hope this work clarifies what we are doing so far. If it's not too clear, please pause the video, go back a little bit, and start it all over again, and you see that it will start coming out clear. If you're tired, exhausted, stressed out, take a little break, grab some water, and come back again, fully strong. All right. So now, the next problem we have, the next problem that we're going to be solving, is that we'll be given an operation star. We're given an operation star, and they're saying that this star is defined. This star is defined on a set of real numbers. Is defined on a set of real numbers. On real numbers by this, where you have A star B is equal to A plus B plus AB. So that's our binary operation right there. Now we're being asked to find, we're being told to find 3 star 4. We're being asked to find, let me write that again. 3 star 4. Now we can tell this is our A and this is our B. So wherever we find A, we put 3 there. Whatever we find B, we put 4 here. You can tell right here. This is our A. This is our B. This is our A multiplied by the B, which is 4. And then we end up getting a 7 plus a 12, and the answer is 19. Right there. Now, we can also be told to find 1/4 or 1/4 star 3/4. Now we know that this is our A and this is our B. So our A is 1 over 4 plus our B 3 over 4 plus 1 over 4 multiplied by the B, which is 3 over 4. Now we end up getting a 4. If this multiplies this, we get 4. If this multiplies this, we get a 12. Divided by this multiplying this, we get a 16 plus we end up getting this times this gives us 3. This times this is also gives us 16, and we end up getting a 16 over 16 plus a 3 over 16. Now, because the denominators are the same, we can have one that has the same denominator and just add the top, add the numerators and get 19. Or you can go through the route of multiplying this and this, adding it to multiplying this and this, divided by this, multiplying this and this, but the numbers are just going to be too huge for whatever we are trying to, for whatever we are trying to achieve. And this can be written as one whole number, 3 over 16, like this. As a mix, we can express that as a mixed fraction. Now imagine that another problem. We've been given an operation star, and is defined on a set S, where S has the members A, B, and C. These are the members of the set S. Now a table is given on star, where you have A, B, and C. You also have A, B, and C here. Now, this table is already completed. We have an A, we have a B here, a C there, but we have a B, C, and A, and we have a C, A, and B as the elements in the table that we have completed. Now, the question says we should be able to determine whether or not the star is the binary operation star. Is it commutative? Is it commutative? That's the question. We need to find out whether the binary operation star is commutative or not. We need to be able to determine that. Now, we remember that we said that for something to be commutative, A star B should be the same as B star A. Or if you have B star C, it should be the same as C star B. If this condition holds, it means that the set S is commutative. The set S is commutative. So if we take something like B, we have B star A. Can you see that? B star A. From the table is given as B. B star A gives us B. Now what about A star B? What does it give us? A star B also gives us B. So far we are getting somewhere. Now let's try another thing. Let's say B star C. What is B and what's our star C? It gives us an A. What is a C star B? What is our C star B? It also gives us A. So far, we can be able to tell that, therefore, the set S is commutative. Our set S is commutative. Our set S is commutative. It's commutative. Now, we're going to be looking at another problem here. We're going to do a different problem here, all right? And the first question says that we still have an operation star. There's a star operation, and is defined over a set of real numbers, or a set of real numbers. Then that means the numbers and the members are all real numbers. And that operation star is giving us A star B is equal to A plus B plus AB. Now we're being told to find 3 star 4 star 1. 3 star 4 star 1. Now we always say that we should start the one with the parentheses first. Now it means this is our A and this is our B. Can you see that? So we're going to have 3 star. This is going to be equal to 3 star into parentheses. Our A will come. Our A comes, which is 4, plus our B, which is 1, plus our A, which is 4, multiplying our B, which is 1. Now, when we do that, we have 3 star into parentheses. We have 5 plus 4. And then we have 3 star 9. We have 3 star 9. And then we can be able to complete that. Now, this becomes our A and this becomes our B. Our A there is 3 plus our B, which is 9, plus another A, which is 3 multiplying the B, which is 9. We have 3 plus 9, which is 12, plus this times this gives us 27. When we add that together, we end up getting a 39, a 39, a 39. And that's our final answer. That's our final answer. Now, the next question attached to it is saying that we should be able to show, we should be able to determine if it is associative. We should be able to determine if it is associative. Now, for something to be associative, sorry about that. For something to be associative, give me a second, please. For something to be associative, we have to follow a certain formula. And that formula says, if you have A, if we have A star B star C, that should be the same as A star B, like this. Yes, star C, like this. Now, the question we've been given so far, we were able to solve 3 star 4 star 1. That's what we did, and we're able to get a 39 as our answer, right? We got a 39 as our answer. So for us to be able to confirm whether this operation star is associative, it means the left-hand side, which is the 39 that we have, should be equal to the right-hand side as a 39. But we need to solve that first. So to have our A star B star C like this is the same as our A is 3 star our B, which is 4, star the C, which is 1. Because this is A, B, and C. That's what we are just doing. So now we're going to put it into the formula, our operation star. Now we always work with the one in the parentheses first. Now this is our A, so our A becomes 3. We are following this formula right here. Now we have our 3 plus our B is 4, plus the A, which is 3, multiplied by the B, which is 4. And we end up getting this, and this is 7. This and this becomes 12. And then we end up getting a 20, is it 29? Let's take it again. So we have a 3 star 4 star 1. Now this becomes 3 plus 4 plus 3 times 4. The 3 times 4 gives us 12. The 3 plus 4 also gives us 7, and we end up getting a 19. So far, we can be able to see that our left-hand side and our right-hand side, it's not the same. It's not the same. So since it's not the same, we can be able to tell that our star is not associative. Our star is not associative. It's not associative at all. Now we're going to look at a different problem. We'll look at a different problem set, because we said that here is going to give us 19. It's going to give us 19. Therefore, the operation star is not associative. It's not associative. It's not. Now the next one that we're going to do, we're going to be looking at a situation where we are given this as our binary operation. A star B is half of AB. That's our operation, right? And we are being told that if we have A to be 4, and we have B to be 6 and C to be 8, we should evaluate. We should be able to find or evaluate A star into bracket B plus C, like this. We should be able to do this. We should be able to do this. So to do this first one, we know that our A is 4 star, our B is 6, plus our C, which is 8, plus our C, which is 8. and then we end up getting 4 star 14, and then we plug it in. So it means that we're going to have our A. We know that our A star B, which is half of AB, is going to change kind of, because we have 4 as our A. Star our B, which is 14, is going to be half of the A, which is 4, and then the B, which is 14. And we end up getting half times 4 times 14. Now, this 2 will cancel out to be 2, and you end up getting a 28 like this. We end up getting a 28 like that. Now, if we're also being told to find or evaluate A star B plus A star C, we're being told to do this. We're still going to be able to plug in our A. Our A is still going to be 4. The B there is 6. Plus our A. Which is also 4. Star our C, which is 8. And then we should be able to solve this. Let's do this separately. We should be able to do this separately. But remember, to do this is our A. Is going to be our A, which is 4, and these are going to be our B. And we know it's supposed to be half of AB, right? Plus, this is also going to be half of A, which is 4, and the B, which is 8. And then we end up getting, this will cancel this out to be 2. And we end up getting half of 4 times 6. This goes here to be 2. And we have 12 here. Plus, this is also going to be giving us half times 4 times 8. This goes here 2. And then we end up getting 16. And we end up getting a 28. And we can be able to see that the two results are the same, telling us something. It is telling us something. And that's distributive. It means that operation star is distributive. The operation star is distributive. We can be able to see that the operation star is distributive. Because from here we started from here to give us this 28. Now we've also been able to do we were able to work out this to be able to give us that. So it means that if you have A star B plus C is the same as A star B distribution over A star B plus A star C. And we ended up getting this. We realized that this whole thing ended up giving us a 28, and this side also giving us a 28. Therefore, the operation star is distributive. It has the distributive property. It's distributive. I hope this, cleans up, beautifully and nicely. We've been able to look at a problem situation regarding whether operation star is commutative, whether it is associative, and whether it is also distributive. Now let's continue solving more problems. Yeah, that's what we are here for. If you haven't yet subscribed to our channel, please do us a favor by subscribing. And if you are already a subscriber, we thank you for supporting our channel. All right, now the next question says, we have an operation star, a binary operation A star B, and it's expressed as A plus B plus AB. All right, this is the expression right here. And we've been told to find the identity element. We are supposed to find the identity element. We need to find the identity element. Now, to find the identity element is a certain property. We need to satisfy this property. The property says that A star, the identity element E, or we can say that we can first of all say that let E be the identity element that we are looking for. So that A star, the identity element, should give us A. Or the identity element star A should also always give us A. So this is a property that we are going to use, which simply means that If you have A star, the identity element is the same as the identity element star A to give you A. So you can tell that it is commutative. The binary operation star is commutative. A star E is the same as E star A, but it's going to give us A. It's going to give us A. So we're going to make good use of this property to be able to arrive at our identity element. Now, I'm going to write it over here. We are saying that A star E is equal to A, right? Now we already know that our A star B is rather what? A plus B plus AB. This is our binary operation. Therefore, what we are looking for is A star E. Is good. A is still going to be the same, but our B is the identity element. Can you see that? Our B is the identity element. We put it there. Plus, this A stays the same because yes, A and this is the identity element. So the identity element is taking the position of the B. Now we are using this because that's what we're given. Don't forget that. And the B here is going to be the identity element like this. All right. Now, once we've been able to get this so far, we should know that this A star E that we've written here should always be equal to A, because we said A star E is equal to A. Now we've written A star E, which is this, is equal to A. Therefore, A plus the E plus the AE is equal to A. Now remember, we're interested in the identity element, so E will stay here, plus the AE is going to stay here. This A becomes here, and then this one moves there. It becomes minus A. And you have E plus AE is equal to 0. We factor E out, we get 1 plus A is 0. Now we are going to divide both sides by 1 plus A. Divide here by 1 plus A. Therefore, our E is 0 over 1 plus A, which is 0. So therefore, our identity element is 0. Is 0. Our identity element that we've been able to find is actually 0. Our identity element is actually what? 0. Now, let's look at another question here. Let's look at a completely different question. Now, the question says that we also have a binary operation again. There's a binary operation star expressed as A star B as A plus B plus AB. Yes. And our A and B, they are all in real numbers, or they are all real numbers. They belong to real numbers. Now we're being told to find the inverse. We're being told to find the inverse. That's what we're looking for. Now, to find the inverse, we'll first of all say let this symbol here be the inverse of A. Let it be the inverse of A. And if that's the case, there's this property we're going to use. We shouldn't forget that. The property says that A star the inverse of A star the inverse of A, should also give you the inverse of A. This is different from the identity element, where you have A star, the identity element. It doesn't give you the identity element, it actually gives you A. But now if you have A star, the inverse of A, we are saying it should always give you the inverse of A. That's a property we are going to make good use of. Now, if we also want to look at the commutative property, it means that an inverse of A star the A, yes, an inverse of A star the A, yes, an inverse of A star that the A should give you the identity element. It should be able to give you the identity element. So let me take that again. Let's scratch this again and take it again, please. Let's take it again. We are saying that if you have A, let me take a pen. If you have A star the inverse of A, we are saying the same as the inverse of A star the identity element. The inverse of A star A star the inverse of A star A, that's the commutative property, which should give us the identity element. So pretty much We are saying that if you have A star, the inverse of A, it should give you the identity element. You remember we have A star, the identity element gives us A, right? Gives us A, not the identity element. It gives us A. This time, if you take A with the inverse of A, it gives you the identity element. In the same way, when we turn it around, if you have the inverse of A star A, it should also be able to give you the identity element. And once we get the identity element, both of them should give us 0. And both of them should also be able to give us 0. So we are going to make good use of this property. So don't forget, don't throw this property away. A star, the inverse of A, is should give you the identity element. But when we are dealing with identity element, A star, the identity element gives you A. With inverse A star, the inverse gives us identity element. Or inverse of A star, the A also gives us identity element, which should be able to give us 0. Now remember, we have been given this property. We are going to make good use of it. We have been given A star B to be A plus B plus AB. But now we're looking for the inverse. So it is A star, the inverse of A, right? That's what we are looking for. Let me rewrite it a different color. I want to write it with a different color. We're saying that if you have A star, the inverse of A, because we're looking for the inverse of A, this A stays the same. So A is here, we write it there. But our B is the inverse of A, so plus the inverse of A, plus our A, which still stays the same, and our B, which is the inverse of A, which is the inverse of A. Now we are looking for the inverse of A, don't forget that. Now, the inverse of A, all of it has to give us 0, right? All of this should give us 0. This A star, the inverse of A, gives us 0. Do you remember? A star, the inverse of A, is the identity element, which is 0. So that's what we've done here. We are saying that A star, the inverse of A, it gives you the identity element, which gives 0. But now we have A star, A inverse, which gave us the A plus the inverse of A plus A multiplied by the inverse of A, giving us the identity by itself 0. So we are saying that A plus A inverse plus A multiplied by the inverse of A is 0. That's what we're saying. But we're looking for the inverse of A. So this stays here, plus this also is here. It's all 0. This goes over here to be minus A. And then we factor inverse of A out. We get 1 plus A is equal to minus A. Now we're going to divide. We're going to divide. And when we divide, by 1 plus A, this cancels out, and then we end up getting the inverse of A is negative A over 1 plus A. Can you see that? Yeah, 0 over negative. So basically, we can rewrite it here. I can rewrite it and say that our inverse of A is equal to 0. It's equal to, negative A divided by 1 plus A. This is what we were able to arrive at. So if we're being told to look for the inverse of 1, let's say we find the inverse of 1, then it means that this will be negative 1 divided by 1 plus 1, which gives us negative 1 over 2, and that gives us negative half. So the inverse of 1 is negative half. It's negative half. I hope this works. I hope this works. I think that I'll end here as our first part video on practicing question on binary operation. At another time when we come back again on binary operation practicing questions, we will continue with more difficult and more harder problems to solve. Before I go, I'd like you to take good care of yourself, and I'm also going to do the same. If you're not yet a subscriber, please subscribe to our channel and turn on all the notification bells so that when we post a video, you'll be notified. I'll come to you another time. Take care and bye.